D.5 Hints for Final Part 2. 3 questions from question 5 through 7. Let's look at the question 5 first. When we apply the standard merge sort, here I want to check you if you can, if you understand the standard merge sort procedure or not, very basic. Here, the question here give you 11 element array, odd number 11 elements, okay? How many comparisons do we need for the worst case? Worst case, we know the formula, right? The worst case, n plus n minus 1. Yeah. n, 2 arrays, the sizes of 2 arrays. When we do the merge, the worst case. Here, let me use a different number to show you how to do it. Okay, so this one you need to, work it by yourself. Here, when I do the hint, I use 9 element. How about that? 9 element array. Just change to another odd number. Okay, all right, so let me work on it. Here, let me draw this line representing the whole array. Okay, so I draw 9 dots. 3, 4, 5, 6, 7, 8, 9. Okay, all right. Then let's recall the standard procedure of merge sort. When we do the split, we split into 2 subarray with sizes as even as possible. The difference could be at the most 1, 0 or 1, based on even or odd number of elements. If you have odd number of elements, difference is 1. Difference of 2 sizes, 1. If even number of elements, 0, same size. All right, so let's do it. Here, 9, that's 9 elements, right? So odd number difference split in the middle. Yeah, the first split here. 5 element, first subarray, 4 element, second subarray. Then the next split, okay? Each one we do the split, all right? The next split, 5 elements, okay? The first one 3, second one 2, okay? 4 split right in the middle, like that, okay? All right. Then here, when we do the split, when do we stop? What time under, termination condition, right? Yeah. Here, when we get, if the array size is 1, we should stop, right? Only 1 element. You have to stop. Another case we can consider 2 elements, we can also stop, right? Although you can split another time, but 2 elements, the good thing is, if we do not stop, if we do not split, we just do 1 comparison, we can get it sorted. Yes, So in that way, we just stop and do 1 comparison to get it sorted. Although you can split, yeah, but here, to reduce the number of splits, we can modify, right? Yeah, here actually we modify our original standard merge sort a little bit. Yeah. All right. I mean, just to improve the, the whole procedure a little bit. All right. So let's take that. Okay. Yeah. Split. Another split. 2, 1. Yeah. No split because 2 elements. We just use 1 comparison. We just get it sorted. Okay. All right. Here, Let's do divide and conquer, right? After we complete the divide part, we need to do the conquer part. Okay, so each subarray we conquer, so one comparison sorted, conquer it. Yeah, one comparison conquer it. Okay, conquer it. Yeah, so this level, the total number of comparison 4. Yeah, so let me do this way. Next, merge, standard merge step, yeah, using this formula for the worst case. Okay, one by one, yeah, level by level. The next level, so let's merge these two subarrays. Okay, how many comparisons? M plus n minus 1. 2 plus 1 minus 1, that's 2. Okay, or the total number of elements minus 1. Okay, total number of 3 elements. Okay, so minus 1. So we need 2 comparisons for the worst case. Okay, so next, these two merge. Okay, all right, yeah. 4 minus 1, 3 for the worst case. 3. Okay, yeah, so no, yeah, remaining, so no. Okay, all right. So then, so next one, yeah. So let's do, so this level, let's do the number comparison. 2 plus 3, 5. 2 plus 3, 5. Okay, all right. Next, so if we merge these two, okay, merge these two, yeah, total number of elements, 7 elements, right? 7 elements minus 1, 6 comparisons. 6 comparisons, okay? All right, so here, nothing. The last one, nothing, okay? Yeah. 6 comparisons. All right, so then the last level merge, total number of elements 9 minus 1, 8. 8 comparisons. So 8 comparisons, the last level, okay? Yeah, 4 levels of mergers, okay? Total, yeah. 10, 4 plus 6, 10, 5 plus 8, 13, 23, right? Yeah, the answer is 23. Yeah. So that's for the 9-element case. 9-element case. Yeah. Now, can you do the similar procedure, but this time use 11 elements? Okay, 11 elements, the similar way. Yeah. Although the detail part could be slightly different. Yeah. Slightly different. Yeah. But if you pretty much follow this, you know, whole thing closely, you can get the same answer. Yeah. Because some students ask me, how about you merge the last two subarrays, right? So if you do that, yeah. So that's the question. So if you do that, probably, yeah. So I don't know if the answer is the same or not. The answer is the same or not. Yeah. So that's an interesting question, right? Yeah. If the same or not. Yeah. So, all right. Yeah. Okay. So that's the question number 5. Number 6, binary search 15-element ordered array. Assume given key appear in array, and between 5th element and 12th element inclusive. Okay, how many comparisons do we need for average case efficiency? Yeah. Okay, yeah. Hope you understand the meaning. Yeah. Second, let me modify this question. Then I show you how to do it, right? I cannot work on this question directly, but now here, let me modify it. Yeah. So binary search, how about I change 11 here? Okay, 11 here. Fifth element, let me change third element. How about that? Okay, yeah. So then this one, how about I change to, you know, 9th. Okay, so let's do that. Draw 11 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, all right. Inclusive, third 9. So here, the key, yeah, let me just, the key is in this range. So that's the key range. Okay, yeah. These two ends, 1, 2, 10, 11, won't appear in the consideration. Yeah. So now let's draw binary tree for this binary search and see what do we get in the tree. All right. All right, so the tree, the first one we compare in the middle. So key 6 in the middle. All right. Okay. Yeah. All right. Then split. Yeah. Next one, 3 here. Okay, 3 here. Yeah. So 2 subtrees, 3. Yeah. All right. Yeah. Then split 1, 2. Okay. So let me put 1 here, 2 here. Okay. 3. Yeah. So then 4 here, 5 here. How about that? 5 here. Okay. All right. This side, 9. Yeah. Because the one in the middle, so that's 9. Left, right. Left, 7 and 8. We compare 7 first, then 8. The right hand side, we compare 10 first. So you may ask me why you compare 10, not 11, right? Because when we do the split, we use the left median as the median, okay? Yeah, the median, usually you have left median, right median. So here, our median, when we use the median, we mean left median, not right median. By default, we take the left median, so that's why we use these elements. Okay, 7, 10. Yeah, 11 is here. All right, that's the binary tree corresponds to our binary search. Now, look at all the nodes we do not need to consider. So we eliminate. So we erase. Yeah, not erase. We cross them out. Okay. Node 1, node 2, cross out. Okay. Node 1, node 2, gone. Left end. Right end, node 10, node 11, gone. Node 10, node 11, gone. Okay. All right. The remaining nodes, those should be considered when we work on the average case efficiency. Okay, all right, so when we do that, top level 1 comparison. Okay, second level 2 comparison. Yeah, so when you get that, you need 2 comparisons. This level 3 comparisons. The bottom level 4 comparisons. All right, now do the average. Let's take average formula. Okay. All right. First, denominator, how many cases? That's the easy part, so let's do that first. Total 11 elements. We eliminate 2 at the left-hand side, 2 at the right-hand side. We eliminate 4 elements. 11 minus 4, 7. Total cases 7. Then the numerator, okay, yeah. One comparison, how many elements have one comparison? So that's 1. All right. 2 comparison, how many elements in the tree, in the consideration, have 2 comparisons? 2. All right. How many nodes? 3 comparisons. Also 2, right? How many nodes? 4 comparison. Also 2, right? Yeah. See? Yeah. Then you get the answer. Okay? You get the answer. Yeah. So what's that? So 1, 4, 6, 8, right? So 19. 19 over 7. The answer. Yeah. You use this method, this way, this procedure. You work on 15 elements and 2 ends using those 2 numbers. Yeah. Draw the tree, write this formula, get the answer. Okay, so that's the way you need to do it. Yeah. All right, the last question of this video, number 7. Yeah. Heap with 77 nodes. How many leaves are there with the longest path from the root? Here, the main thing is, I hope you understand the meaning. So the main thing, I need to explain the meaning. Okay, yeah. All right, so here, let me work on an example. Let me work on an example, show you the meaning. Okay, then you can solve it easily. Okay, so what's that? So here, let me use 9 nodes. Okay, so make a much smaller heap, 9 nodes. Yeah, then so we just see the from the diagram how to count number of paths satisfy this condition. Then you can do it easily. All right, yeah, okay. Here, 9, because when we draw heap, each level we fill it. We fill it. Okay. So next level we fill it. Yeah. Then the last level we pack in order as many as we can. Okay. That's the way we arrange the heap nodes. All right. So the last one we have 2 more nodes. Yeah. So now 9 nodes, right? So 9 nodes. Okay. All right. Next. Look at all the leaves. Look at all the leaves here. These 2 are leaves. Then these 3 are leaves. So here you can see 2 groups. 2 groups with different longest path. Yeah. Path length different. Yeah. These 2, the path length 3. 3 edges, right? 3 edges, 1, 2, yeah, so 3 edges you count. 1, 2, 3, also 3. So this bottom level, 3 length we called, they have, these 2 paths have length 3. But this level you can see length 2. Length 2. Length 3 group, length 2 group. Here the question, longest path from the root. So we need to count the number of elements in this group. Okay, so for this case, the answer is 2. Okay. Now, you need to work on the 77 nodes. 77, so this number relatively big. Okay. You may not draw the complete binary tree because, you know, You need to do a lot of work. Yeah. But you can imagine, you draw a diagram just to give you the enough information. How many levels do you need to fill until the last level, right? Try to fill all the levels. 77, stop, you fill all the 4 levels. How many 4 levels? Then you have a last level that's not full. Now you count the last level. How many elements in the last level? Not full. Yeah. The number of elements in the last level, how many? Yeah. That's your answer. Okay? All right. So let me finish this part 2 of final. And our D.5. This is our D.5. And we have our last video, 3 more questions. Last 3 questions in the last video.